Welcome to today's webinar. My name is Randy France, and I'm Telecommunication Industry Strategy Lead for ESRI. What we'll be covering today is the fourth in our telecommunications webinar series, Engineering and Design, Reduce the Plan to Activate Interval with GIS. Before we get started, what I'd like to do is cover a few logistical items. On your pop-up window there, you can connect the audio via either a telephone or use these mic and speakers in your computer. You can also adjust your view so you can have full screen view. We also will be soliciting questions during the webinar, so please type in your question and then submit them. And then when the webinar is completed, we'll be then going live and answering any questions that you might have submitted. I'd like to review a few of the other webinars that we have in our series, the ones that we've recorded. Previously in January, we had the foundation webinar that covered some of the basics of GIS technology. It's a great primer if you want to go back and look at that. The next one we had was in March, and that covered serviceability. Biggest challenge a lot of service providers have nowadays is determining service availability, especially when customers need fiber connections and they need to get an estimate for the cost and time to install those fiber connections. In May, we covered bringing the field to the engineer, how you can reduce a lot of those non-productive visits to the field by the engineers by bringing a lot of the data to the engineering desktop. That's the imagery, the network, infrastructure, things like that. Reduces the cost and improves the time to market. Today we'll be covering is engineering design, and I'll go through that a little bit later. And then on October, we have coverage processing and mapping coming up. And then closing out the year will be operational intelligence in December. And those are this year's, and later in the year, we'll be releasing the planned webinars for next year. Joining me today is Patrick Hulls, technical evangelist for telecommunications. He'll be covering a little bit about GIS technology and how it can be used and applied for engineering design. And then Kyle Sanyard, from Director of Product from 3GIS, will be covering some specific tools that and a product that they've built on top of the ArcGIS platform that'll cover some specific engineering, design, and planning capabilities. What we'll be covering today is first looking at some of the industry challenges. We talk to a lot of customers and they tell us, give us feedback on the challenges they have when it comes to engineering, designing new plant. Well, Patrick then will be covering some of the GIS capabilities and the technology and how we can improve those processes. And then we'll turn it over to Kyle for engineering design before closing out with Patrick Hulls, who will be covering how to get started. So business goals really haven't changed over the years. Whenever you're designing and building new plant, and additional capacity is always needed as bandwidth demands grow exponentially, is reducing the CapEx expense. You have a finite amount of capital. If you can reduce and reduce the actual CapEx expense and optimize your design, and say you're saving 15 to 20% on each design, you have a choice. You can either reduce your capital budget or you can build an additional 15 to 20% new networks. The other thing that's really important is reduce the time to market. With the exponential growth in bandwidth demand, you need to get to market faster. If you can't satisfy your customers, you can't deliver the capacity and the capabilities when they want it, they're going to go to the competition. And that's the last thing you want to have. The other thing too is the sooner you get them on the network, the sooner you can get those builds completed, the sooner you're going to start revenue. And that revenue is going to improve your return on investment. So by reducing the capital, getting quicker to market, you're going to get a better return on investment. More return on investment means you have more money to be able to spend on new plant going forward. But there's a number of challenges that you face whenever doing fiber to the home or fiber to the X design. And these are some of the challenges that the customers that we work with tell us that they're faced. First off, some of the goals, they're very ambitious targets. I was at a conference last month, and one of the presenters was up there was talking about they were planning 1 million homes passed. Well, they didn't make that number. So the targets are often very ambitious and very hard to achieve. So those are some of the challenges that we have. The other one is the time to revenue. If projects get delayed, the revenue doesn't come in on time, customers are dissatisfied, or you can completely lose the market opportunity if the competitor gets in there. And the other one is staying within capital budget. I can't tell you how many times we hear from clients that one of the biggest challenges they have is really meeting their capital budgets. It seems like no matter how carefully, how conservative you are, a lot of times when you ramp these things up, the capital budget just doesn't seem to align with what you had originally planned. Now, some of the obstacles that that stand in the way are ambiguous requirements. As I said, a company was looking at millions of homes passed. Well, it's got to be defined down, what type of homes, what neighborhoods, those kinds of things. So you have to have a system that's flexible enough to take those ambiguous requirements and refine them and be able to be flexible enough to deal with them. The other thing is difficulty and cost of scaling. Too often you have a prototype project, you do a small implementation, maybe 1,000 homes, maybe it's 10,000 homes, and it seems to work just fine as long as everybody's focused on it. But when you start moving it out to the larger organization and ramping it up, do you have the defined processes that are going to allow you to be able to ramp that up to 100,000 or several 100,000 homes passed? The other thing is inconsistency of delivery. When you have a team of engineers and they're all doing it in a manual process, everybody's got their own technique. And often that doesn't have alignment with what either corporate wants or consistency across the organization. Too often, also, you have duplication of effort. So people are kind of tripping over themselves as you ramp up these types of projects. So there has to be a way to be able to define the roles, responsibilities, and make sure that you don't have people stumbling all over themselves, doing the same work over and over again, and there's no duplication. And then finally, the one complaint we hear a lot of times is poor documentation. Too often, what happens is when you do these projects, it seems like the as-built is really whatever came out with the engineering plan. So too often, it's considered non-productive work to go back and correct those engineering drawings, and therefore the as-builts really don't reflect what currently exists in the field. So what we'd like to do now is like to ask a few questions of our audience, get you involved. We're going to ask a question here. So why don't you let us know what are the biggest network planning challenges you face? So just click on the answer that's most appropriate. Is it short delivery times? Is it availability of skilled resources? Maybe you don't have enough the engineering and staff that you need. How about estimation of accuracy? Do you have, are your estimates coming in accurately? And then finally, one that is always a challenge is the field-driven design changes. So let's take a few minutes here, and then we'll share the results here. We still have a number of responses coming in. All right, wait for a few more in there. All right, so let's look at the results here. It looks like it's really, edging out slightly was field-driven changes. Those changes, as I was talking a little bit earlier about the as-builts. But it's close there. It seems like all these are really hot buttons for everybody. So obviously you're facing a lot of different challenges out there. Let's go to our next poll question. So the next one is, we're going to be talking about some of the tools that GIS offers, and specifically some of the ones that 3GIS has. So where would automation help you the most? Is it in project delivery time? Maybe that's your hot button. Or would it be enable alternative design comparisons? Give you a chance to look at various scenarios. Field to office changes. That came in pretty high last time. Or improve design consistency. So out of these, which do you think automation would help you absolutely the most? Still got a few votes coming in here. All right, get ready to close it out. One last chance. There we go. All right, let's see what kind of results we have there. All right, where would automation help you the most? It looks like enable alternative design comparisons and improve design consistency. That's what we hear a lot about from telecommunications companies. Those are the hot ones, although project delivery time and field to office changes was equally as important there. So that's great. What I'd like to do now is I'll turn over to Patrick Hulls, and Patrick will tell you a little bit about the technologies that GIS brings that can be leveraged and help you in automating some of the design and planning processes. So Patrick?
Thank you, Randy. So seemingly GIS and mapping has always been in the network engineering and management space, really providing map visualizations of outside plant, providing paper maps to field crews out in the field, spatial analysis to help map and optimize for network planning, and then network data management for once it's actually in the ground, managing the physical network and also the logical connectivity of how everything is connected up. But over the years, as technology has evolved, so has GIS into what we call web GIS. And this notion of web GIS has really revolutionized how we plan and design by taking those same great GIS capabilities and exposing them through the web to anyone in the organization and really anyone in that whole end-to-end process who needs to be able to have access to the maps and the analysis tools to be able to do their job in that whole end-to-end workflow. And so now GIS, where maybe it was just in the engineering and design office, is now being exposed to the entire organization to help the whole process, from analyzing initially where to deploy new network. So understanding where you have that high return on investment opportunities in the high demographic neighborhoods that you're trying to target, to helping with the actual design. And so optimizing those fiber to the home builds. So being able to take a list of addresses, bring them into the GIS and have the GIS plan out what those routes would be automatically, instead of taking a long time to figure out how to connect it all up using maybe a paper map method. Then with those automation tools, being able to evaluate multiple designs. So depending on how a particular design is going to affect your network with existing capacity and bandwidth, you can do automation and through this design process to help evaluate these different potential builds. And throughout the whole process, visualizing kind of the end-to-end network. So being able to start with the initial plan to the engineering and design final results, to taking that out into the field and being able to visualize that in the as-builts, and throughout the whole process, disseminating all of this information to anybody who needs to have eyes on this particular project, including the management teams, to keep them up to date throughout the entire network build. And so ESRI offers a complete and integrated web GIS platform called ArcGIS. And ArcGIS provides these mapping, analysis, and data management capabilities to the entire organization through a services-oriented architecture. And this type of architecture can really increase collaboration, again, from the beginning plan to the engineering design to the construction and the management of the entire process. And the great thing about the ArcGIS platform is that it allows for partners to build really complete telecommunication solutions that incorporate these GIS capabilities, and they can build them right on top of ArcGIS. And 3GIS is just one of those partners that have extended the ArcGIS platform with very extensive engineering and design and network management solutions built right into ArcGIS. And so now what I'd like to do is turn it over to Kyle Sanyard from 3GIS to really talk about some of the solutions that 3GIS has to offer and how they have been providing additional value to their customers.
Thank you, Patrick. I just want to start off. I know that everyone on this call knows the impact that fiber is having on the world, but I want to offer up a couple of numbers just to discuss how expansive this growth is predicted to be. An impact report with Chalmers University of Technology isolated the impact of broadband speed, showing that by doubling the speed in an area, an economy increases GDP by 0.3%, which is equivalent to $126 billion. And FTTH goals in OECD countries, by 2025 is 95% penetration. That's a 16% compound annual growth rate from 78 million destination points in 2016 to 1.3 billion by 2025. And worldwide small cell backhaul growth is projected from 109,000 connections in 2016 to an installed base of 1.9 million by 2020. So all of these connected things and people are just creating an expansive need for more fiber to the destination point and backhaul to the core. And I think that's why most of us are here today. We see that. So the first step in trying to solve the problem is really understanding what the problem is. And a lot of what we saw inside the polls that we just provided kind of speak to the same things that we're seeing in the market. So first, the time to construction, which has historically consisted of manual processes, which with the variability in permitting requirements and output, along with the inconsistent output that you mentioned that you're getting, that makes meeting these deadlines and estimating the cost a bit of a crapshoot, I'd say. And not to mention the overall lack of a view into the macro network. So sticking into these small areas and not really understanding the full breadth of what you're trying to design. Then comes the cost of construction, where the challenges are very similar, just with minor tweaks in terms of you're continuing to get inconsistent materials, which creates a logistics nightmare when trying to estimate your expenses. And just like permitting, the consistency of your output is crucial to the success of your construction teams. And by simply developing this consistency through automation, you're creating efficiencies in your build already. And then as we saw, getting the proper information back from the as-built is another huge barrier. So in the past, it's been a nightmare trying to get that back, forcing you to revisit and correlate what you designed with what was actually put inside the ground, all running you into a wall that will eventually hit when your geographical as-built understanding of your plant doesn't match what's actually out there, making the maintenance through the life of the network a very daunting task. So now we understand the problem. We want to look at what others are typically doing today, which really isn't much different than what it was 20 years ago. So traditionally, all this has been done in CAD, which offers more or less no spatial understanding to what's being designed, which creates segmented designs that make it difficult for PMs to really understand what's going on throughout. And decisions are being made across the market without this understanding that affect it down the road. So, and then God forbid you have a wholesale change to the design and trying to deploy that throughout, it just becomes a nightmare. And if we look at the workflow of how things have been done in the past, we can see that everyone more or less works inside their own silos. You know, they're unaware of anything that's happened before or even after they've done their part. So this lack of collaboration really creates hurdles as you move through the design and into construction. We all know how difficult it is to deploy an outside plant network on all kinds of fronts, right? The planners, the engineers, the operators, the construction crews, all of that. The geographical areas that we're building inside of, they restrict and demand certain planning and design decisions be made that impact not only the cost of the construction, but the maintenance of that network through the rest of its life. So working through the spatial data factors like railroads and rivers and streets, and be it interstates or whatever, the local permitting requirements that are different in almost every area you go to, and sometimes inside the same area, the technological architectures that continue to come out, makes it very difficult to meet the expected business needs at a timely manner and at a costly, you know, it's a very costly process to get there. And those processes can extend for years, all up front of the revenue. So it's easy to understand why engineering firms are very interested in, you know, how can we accelerate our path to earnings? Because that's always the bottom line. And so how do we help? You know, how do we accelerate this process? And at 3GIS, we believe that's through GeoDesign, which, you know, allows network providers to take advantage of existing geographical data, historic build cost, and much more, depending on what they have, to quickly and accurately design a fiber network. And so this kind of all takes us back to what Patrick spoke on. So through the ESRI platform, we've been able to offer visibility for everything from the planning to the managing of that fiber network throughout an organization. Offering, you know, 100% web and mobile access. It's always available to everybody, everywhere. And through automation, we're able to develop these consistent and accurate designs in a faster time than ever before. So I'd like to step right into a demonstration of a tool that we call Prospector that we've just recently released that we're very excited about. So Prospector is a tool that helps to get you a high-level estimate of what the construction will be so that you can understand, you know, is this a viable option for my company to even bid on, for example. You know, we've heard multiple stories from our customers about receiving hundreds of demand points from providers with an expectation that bid packets come back in weeks and sometimes even days. And so with Prospector, you're able to, you know, run various routes and optimize them for the best economic success of your project. So let's just kind of jump right into the demonstration. So the first step is going to be loading in the demand points that I received from the provider. And what you'll see here is I just have a simple CSV with the Latin long and some of the spend and the types of demand points that I'm trying to serve. So I'll simply drag and drop this on the map. All right. So the next step is to kick off my project. So I'm going to give my project a name, and I can also view existing projects should I choose to do so. So I'll just give this one the name ESRI Webinar. So my next step is going to be to load those points that I've just drag and dropped onto the map into my enterprise geodatabase. So that's pretty powerful in that as soon as these get into your database, they're available to everyone to analyze and use going forward. So I'll simply load in those prospects, give it a name field, and import those into my geodatabase. So you can see down here some of the different points. I can manually add these points as well. So if I'm, you know, a sales rep or something like that, and I get a call in, I can go and place a point at the address who's looking for me to give them service and understand, you know, what is it going to take to actually get service to that location. The next thing I'll do is to tell the solver here, what are the different assets in my network that I'm going to allow this to tie into? You know, does it need to go back and strictly look for fiber equipment? Am I looking to tie into any splice closure in the area? Or, you know, maybe I'm even saying just find me the closest fiber cable and I'll splice off of that. So for this example, we're going to do a splice closure. So this is another function inside the tool. And if the data is available to you, you can start to set buffer distances around your routes to look for existing businesses in that area to help you make some decisions on, you know, do I go down First Street or is 3rd Avenue a better option because there's more businesses in that area? You know, this data can come from anything like a geo results, for example. And so I set that distance, and then I can understand, you know, going down this path, I'm potentially going to run by 5 other businesses, and maybe I can go ahead and give them a call and see if they'd be interested in purchasing some dark fiber from me. And finally, I can draw barriers in should I see that a necessity. You know, if I understand that this is a path that I'm not allowed to go down, I can draw in barriers that the solver will then look to route around when it finds that optimized path to that demand point. And finally, I'll just ask it to solve. I'm going to turn on some layers here. We'll turn that back off. Let's see if I can come back. We'll come back to our results. And as you can see, it's kind of trickling in here. We can continue to refresh. So I had 9 points that I was trying to solve for, and you'll see this is all in real time. So you'll see just how fast this information comes back. And our last one, obviously, the longer the route, the longer the solve. And there we go. We have our final route designed. And so if I expand this out, what I'm looking at here is a view into the demand point that I was serving, where in my network I tied in to serve that point, and then the length of that route. And by using what we call cost regions that are set by the user, we're able to give an estimate on the cost of that build. Now this cost is, these cost regions set the price per foot to design, but they can also get as granular as, here's my cost for road crossings, here's my cost for railroad crossings, my neighborhood cost, you know, the cost of the crews in this particular area. So you can get very granular to get an even more accurate estimate against this particular route. And then you'll also see the businesses designed over here in that last column. And I can zoom to these areas and get a look at, you know, exactly what's going on. So I came down here and I obviously tied into a handhole and ran up the street here to serve my demand point. I can then look at the information about this route. So it tells me where I tied in. I did not cross any railroads or really roads too much. I had a neighborhood cost of $800 and a crew cost of $500. And with those two expenses, along with the footages, I ended up with a total cost of around $164,000 to build out this particular path. I can look at the cost regions to understand if I went through multiple cost regions or what those prices were inside those regions. And then finally, a look into the businesses that I'm going to pass. So if I were to kind of step down, we can see over here that these are the businesses that potentially we could serve with, you know, maybe a few more, a few extra capacity as I build this out. So that's our prospector that helps with a high level estimate, and something that we're really excited. Now, I'm not going to show it today, but something that we're really excited about is the expansion of this tool that we continue to work on, which will take these paths that are decided as viable options, and actually turn this into a detailed design. Building out the capacity, understanding the source that's going to serve it, and building the capacity to each of the demand points, along with placing splice closures, different equipment types, and then your structure locations and things like that, to really help you get a leg up on your fiber design. And so we'd love for everyone to contact us and show you what we've done. So now back to the presentation here, and I will mention this YouTube link here is just a video of the Prospector functionality that I just demonstrated. So as we've looked at machine-assisted geodesign, what we've seen in the market is that it's all started out with the engineering services taking care of all of the design, but what they saw was a really high cost with very little throughput. So not quite as many premises as they desire were designed in the time frame that they had to meet. So they started to kind of move to some of this offshore, and what we saw there was higher throughput with a lower cost, but still, based on the crazy time frames that Randy mentioned initially, that just wasn't enough. And so, by automating, we've been able to substantially decrease the cost while increasing the throughput. We've seen numbers as high as 600% increase in time to permitting, which we know it can be a long lead time and something that's completely out of your control. So getting to permitting as quickly as possible is critical in the success of your fiber build. But potentially more important here, and you'll notice here on the dotted line, is the iterations. So by increasing this design time, or shortening the design time, I should say, it starts to allow firms to iterate through and understand alternatives inside their design, allowing you to make the most optimal fit for your needs, which I know is another outcome of the polling, that iteration is kind of one of the major hurdles as you go through designing a fiber network. And then, with the power of ESRI, we've been able to create also a single source of record. That allows the design teams, along with the construction crews and everyone involved, the ability to create consistent output, make efficient design changes, and input accurate as-built data that becomes invaluable down the road. So everyone's kind of playing on the same sheet of music, I'd say. So by having all of this in a centralized location, we're able to get into a much higher level of detail inside of a mapping platform that really hasn't been seen before. This allows the engineers, the municipalities, and the crews to drill down to view very specific details inside of this design. Everything from dimensioning lines to the dynamic labeling that's available to you. And then once this design is finalized, through things like SQL queries on the back end, our tools are able to quickly get an estimate of what is to be built. So be it a bill of quantities, a bill of materials, your labor cost, all of that is essential in understanding the design and the build. And so by speeding up this process, you can really quickly understand the cost for the network construction, which helps you reduce the overall cost of actually deploying the network. And I think a lot of you would agree, the other piece of this puzzle is it gets you ahead of the procurement phase that so often hampers the build. You don't want to be in the back of the line when you're trying to order all of the network equipment that you need. So on top of the BOM, based on the network design and doing so on a map, you're able to take advantage of supporting data that exists to automatically generate things like dimensioning lines and labeling dynamically, which creates a very unique ability to quickly and accurately develop prints for both permitting and construction. And then finally, you know, an often overlooked piece of this puzzle is the information that's necessary to actually manage the network going forward. So 3GIS is unique in its ability to help with the automation of the design, but you know, our history goes back to actually managing a fiber network. So the 3GIS system provides tools needed to understand every element that makes up every path to every customer, allowing you to troubleshoot more effectively because, you know, based on a lot of different SLAs, the troubleshooting of issues with existing clients is time consuming and penalties are at risk most of the time. So knowing how every port or fiber work together in one system kind of allows this insight to help and support your customers as you move forward. At the same time, it offers views into how the network can be expanded and utilized over time to build more revenue for your organization. So Patrick, I will hand it back over to you.
Thank you, Kyle. All right, so thanks again. Some great examples of how WebGIS and GeoDesign can be applied to the whole engineering, design, network planning, and network management lifecycle of this entire process, and really showing the power of GIS capabilities and how the ArcGIS platform can enable these very detailed and extensive solutions like 3GIS Web and 3GIS Mobile and the new solution Prospector that 3GIS has to offer. And the great thing about a solution built on ArcGIS and incorporating 3GIS is that you get the rest of the ArcGIS platform and all that ArcGIS has to offer. For example, ArcGIS includes a ton of configurable out-of-the-box applications that you can leverage with the solutions and the apps that 3GIS provides. One of those being Operations Dashboard. So a complete dashboard application that you can configure to consume data coming out of 3GIS. So if you want construction teams to have insight into the status of a certain leg of the project, you can configure the dashboard to give them those KPIs and those metrics in real time coming from the data that 3GIS has shared through the WebGIS. You also have a lot of field applications that are part of ArcGIS. So if using 3GIS Mobile for one particular workflow, you come across another workflow that you'd like to spin up, you can take that same data, you can create a new web map, and you can consume it in a field application for collecting data, viewing data, navigating to a particular location, and even collecting LiDAR information from a drone that you might want to include in your whole end-to-end network build-out process. We also have a new application called Insights for ArcGIS. So this will allow you to get additional detail and derive new trends and patterns from data that you are collecting. So as Kyle mentioned, part of the process is once you have the network built and you have it lit up, is being able to manage that asset and the entire network. So tapping into an existing OSS, pulling in real-time asset information and looking at bandwidth and capacity down to the asset level, you can record that historical information in ArcGIS and use Insights, which is an exploratory application to really dive down, look at charts and other types of widgets and maps, and really look to see if there's any insightful information that can be derived from the data that you're collecting. And of course, ArcGIS is now IoT and big data ready, so you can tap into all of that real-time information, all of that big data. You can store it and manage it in ArcGIS, and you can share it throughout your organization, and including sharing it back into the 3GIS solutions. So how do you get started with all that you just saw here today? Well, first off, deploying your WebGIS foundation is key. Once you have that WebGIS in place, you can start tacking on these modules or solutions on top of it, including all of the 3GIS solutions that we saw today. Once you have that WebGIS in place, start looking at the 3GIS capabilities and seeing if any of them will be applicable to your workflows today. And any of the pain points that you have, 3GIS might be able to resolve with some of their solutions. Once you have some of those 3GIS solutions in place and you're getting that return on investment, start looking at the rest of the ArcGIS platform and all that it has to offer. There are a lot of other configurable apps and ways to leverage the data that you are creating in the 3GIS solutions in the rest of your organization by sharing it through the WebGIS and through some of those configurable apps like the dashboard app. And finally, if you have any questions about what we've shown here today, please feel free to discuss all the different engineering and design solutions with either your ESRI representative, with Kyle and 3GIS, or feel free to just send us an email and we can direct it to the right person. And so with that, I'll turn it back over to Randy, who will open up the floor for questions.
Fantastic technology out there. Thanks, Patrick. Thanks, Kyle. We'll open the floor for questions now. We've had a number that have come in. One of the first ones that came in was really a logistical question here. How soon do you have the webinar available online? We should have this online in about a week. So expect to be able to find it next Thursday or Friday. So if you missed a portion of it, maybe came a little bit late, just click on and you can see it. Let's go to some of the other questions we have here. This is a good one. So how many engineers will design automation replace? Who wants to take that one? Is that you, Kyle?
Yeah, so I'll take that one. That's a great question, and it's one we hear all the time. And I think that's also where a lot of the confusion comes in when people discuss automation. We don't like to talk about design automation as a replacement for engineers, but instead as a way to speed up the process to allow companies to bid, win, and complete more work with the same teams, or to even stay ahead of construction so that field crews are never waiting on an engineering team. With today's technology, an engineer still needs to review, adjust, and finalize a design to ensure it's compliant with the design specifications and the requirements that you're seeing in your market. Having said all that, we're seeing around a 50% reduction in design time for most of the FTTX projects that we've been involved in.
Okay, great. This one's probably for you, Patrick. Where does the business layer data come from?
Good question. So the business layer data can come from a variety of different sources. One, it can come from your own organizations and maybe your marketing or sales team that have been curating these databases of prospects. Taking that list from either a database or a spreadsheet, quickly geocoding those addresses, that layer can be included in Prospector and really within the ArcGIS platform. Or we also have quite a few premium content or data providers that can provide this business data. One of them Kyle mentioned, ShareTracker or GeoResults can provide these business locations with very extensive additional information on those businesses, like how much they're spending on communication services and what is their anticipated bandwidth usage.
Okay, good. Does this program only solve for short-run urban commercial fiber expansion, or could it be also used to look at neighborhood fiber expansion, both urban or rural? I think that one's for you, Kyle.
Yeah. No, so what that tool that I showed earlier looks for is really just a source point. So what we've seen customers use Prospector for in the past in areas that they didn't have existing plant is a lot of times they do know things like the cabinet locations. So if I have a cabinet location and the demand point that I'm trying to serve, the tool is able to route back to that particular head end or cabinet or whatever it might be and show you the most optimized path to each demand point.
Okay, so I'd say,
yeah.
All right. Here's one I think for you, Patrick. Question, if we had our own information, could we use that and integrate that in the system?
Yep. So just like the business data, whatever information and data that you have and that your organizations are curating, if it's got a spatial component, if it's got an XY, a lat long, an address, if it's coming from a variety of other spatial systems and platforms out there, we can bring that in. You can visualize it, you can analyze it with all of the different tools and solutions that ArcGIS has to offer, and start really building those GIS databases. So every time you do one of these engineering and design projects, as you're collecting data from the field, as you're collecting data from other sources, you're building up these very rich data sets that can only enhance the engineering and design process.
Thank you. Here's one product question, Kyle, for you. Will Prospector be functional on ArcGIS standard server license at some point?
We are looking into that. What we take advantage of from the ESRI suite is, we take advantage of the network analyst extension to ArcGIS server. So at the moment, that's not something that we're able to do, but we're continuing to work with ESRI and understand the possibilities as we move forward into, if this can fit inside of a slightly different licensing model.
Very good. This one's, I think, is for you, Patrick. I would like to know how to get the geodata, the map.
The geodata, the map. So there's maybe a few ways to take this question. First off, the base map, so the source map that all the data kind of sits on top of. ESRI provides a variety of different base maps out of the box, whether that be aerial imagery, topographic, street map, and even some open source ones out there like OpenStreetMap. So we manage and curate and build those base maps and provide it through ArcGIS, which you can leverage either using out of the box in ArcGIS or through a lot of our developer tools. A lot of the times what we see is that organizations and customers really use us as a mapping platform, meaning we'll provide the base map, but it's really our customers who build the maps. So it is our customers who take their data and start adding them on top of the base map and really building their service territory map, their network map, their customer map. So we're really a mapping platform that enables users to build maps. So if you've got the data, you can start building your own maps. And if you're just looking to get access to our base maps, we've got a developer framework to do that as well.
Okay, good. A couple questions here for you, Kyle. Can you collect as-built data electronically?
Yes. So through our mobile application, which I didn't show or really mention here, we're able to share and take advantage of the ESRI's Arc server to capture data in the field, both in a disconnected or a connected state, that can then be pushed back to your enterprise geodatabase for everyone inside of your organization.
Okay. Question about implementation of Prospector. Is the 3GIS solution only available via 3GIS services, or is it a software package that our team can implement?
No, great question. Everything that I've shown today is part of our product line. Prospector is a very recent release for us, but it is available to any of our customers who are looking to utilize its capabilities.
Okay. A data storage question here. Is data stored in a relational database or a SQL database?
All of this data is stored in a relational database. So we're using the ESRI GeoDatabase, and this particular one that you saw me show today is in a Postgres, but that could be Oracle or that could be SQL, whatever it is. But it is a relational database, and that's how we manage the light path as you move forward through the design and into the managing of the network, that relational database allows us to get down to the fiber and port level against each of the cables and the equipment that you have to develop connectivity to help you understand, how your network is being operated. And that's also comes in a big advantage when you're doing the design as well, because it helps you understand the loss and the ability to see, am I actually serving this customer? Can I trace back to the equipment that should be serving them? Or am I missing something in terms of the capacity that I've built out?
And here's a question we have relating working with other systems. Do the services have the capability of taking in AutoCAD data and or outputting AutoCAD DWGs?
So our application does not output to DWGs, but as I mentioned earlier, we are just taking advantage of the ESRI technology on the database side. So there is a lot of potential to convert those DWGs into your geodatabase that can then be utilized inside of our application. And we also have customers who take advantage of the fact that the CAD integration with something like an Oracle or a SQL database, which is where this all lives, can kind of work seamlessly together.
Yeah, and to add to that, as Kyle mentioned, because we're all on top of the ArcGIS platform, you can utilize another ArcGIS tool like ArcGIS Pro to be able to tap into that database and export it out to a variety of different CAD formats. So those conversion tools are part of other applications that are a part of the ArcGIS platform that you can leverage, as well as there is an extension for ArcGIS, and there's an extension for AutoCAD that is an ArcGIS plugin. So you can set up a kind of whole process here to be able to export it out to a variety of different formats, including KML, KMZ, and different AutoCAD formats.
Good point.
All right, here's one again for you, Kyle. Does the Prospector tool take capacity into account when routing to a handhold so that it does not route to a fiber which is already at capacity?
That's a really good question. And right now it does not take into account that capacity where it's trying to tie in, but that is something that we have on our roadmap to understand the availability at each of these structures or splice enclosures that we're trying to tie back into. So I think, sometime in the near future, we will be able to handle those types of design.
Here we have one question about the route selection. The algorithm used to draw the access fiber between the client location and transport fiber is based mostly on the shortest path on the road, or can we personalize the logic behind it?
So it actually looks at two different things, and there's based on the pricing, you can start to personalize the logic behind it. But it looks at two different options based on your settings as to the shortest path to that demand point or the least cost path. So the least cost path takes into account those cost regions that I mentioned and the price points that you put across on top of railroad crossings or interstate crossings or whatever it is to try to optimize the route and avoid the high build cost areas as you try to serve that point.
Here's a question about fiber representation here. How are 144 strand fiber cables represented? One GIS feature or 144?
Good question. That's and I think that's kind of where we differentiate from some of the others, but we differentiate that as one GIS object in the database. So one cable with 144 non-spatial tabular fibers that are related to that cable that allow you to drill down and capture as much or as little information as you'd like to against each fiber inside your network. But it is just one line on the map.
Okay. Here's one about, can Prospector run a cost analysis comparison between aerial and underground?
It cannot right now, and what we're looking at doing to kind of resolve that issue is to allow for different costing regions or multiple cost types. So saying that, you know, this area would be $100 a foot to go underground versus $25 a foot to go aerial. And I think that's something that we'll also be doing in the near future. And the extension that I mentioned, codename Plexus right now, it does take into account some of those things as it starts to do the more detailed design in terms of allowing you to iterate through different architecture types, be it aerial or underground, and compare the output of that.
Does Prospector allow for daisy chaining multiple locations back to the network?
Yes, it does. It actually has a setting to allow you to say whether you'd like to do a home run to the demand point or to daisy chain. And in the example that I did, we actually set it up to daisy chain, but it is just a switch on the GUI that allows you to set that.
Okay. Yeah, we're starting to run close to the end here. What I'd like to do is throw up one more poll question here while we answer some of the remaining questions here. So let me put this up for the audience. Give us some feedback here. Are you actively seeking a planning and design tool? So, please select yes or perhaps no, not currently, or you really don't know at this one point. So give your answers, and we'll be collecting those while we answer a few more questions here before we've got to close out on top of the hour here. Is it possible to include vertical cabling costs into the estimated cost of connecting the prospect? Suppose a client is located in the 30th floor of a building.
Prospector does not take into account the inside plant and risers inside of the building. So no, that's not a current functionality that we have.
One last question here, and then we'll close it out. Appreciate everybody hanging in there. Is it possible to export splice tables from this software?
Yes, our software has the ability to export what we call a splicing report. And so you can do that against one or multiple splice enclosures inside of your network, and by simply selecting them and saying to export them to the tabular format, and in this case it would be an Excel document.
Okay. All right, well, I'd like to thank everybody for their time. Unfortunately, we are out of time. So we appreciate everybody, and I know we did not get to all the questions. They kept coming in here, and I could barely keep up with them. So what we'll do is, if we did not get to your question, we will get back to you. We've logged in the questions here, so we'll get back to you individually. So thank you very much for your time. We know you're very busy. We appreciate you joining the webinar. Don't forget, it will be up and as part of a recording next week, Thursday or Friday. And I'd like to thank Patrick and Kyle for joining us as well. So everybody, have a great day.